Hello, I'm Nicholas Taubert, and this is my second tutorial video for game dev, continuing right from where I left off in the last video. To start, Unity assigned this challenge and initially held several bugs we had to fix. The spawn manager was spawning dogs at the top of the screen instead of balls. The player would spawn balls instead of dogs to throw. The balls are being destroyed if they were anywhere near the dog, like not just if they touched the dog, but like even if they were like several feet away from it. There was nothing being destroyed off the screen, so this hierarchy at the left was filling immensely very quickly. Only one type of ball was being spawned. There wasn't like the difference between these red ones and these green ones and stuff. The spawn interval was always the same for these balls. You might notice now there is like a 3 to 5 second randomness between when they'll spawn, whereas it used to be very exactly consistent. And the player used to be able to spam the spacebar as much as they wanted to make infinite dogs, whereas now we can only make one at a time. So to fix each of these issues one by one, the first one was that spawn manager was spawning dogs at the top of the screen instead of balls. So fix that. And this spawn manager, which is actually at the top, it's invisible, but this is what handles the balls being spawned. And this array at the right, which the array is created in here, it was holding dogs instead of balls. So we had to go to the prefab and actually drag and drop each of these ball prefabs into the different elements to choose from. Next, the player was spawning balls instead of dogs, and that was a very similar solution. And this player game object at the right side, and the player controller script for the dog prefab, even though it's named dog prefab, Unity doesn't naturally know that it's supposed to be a dog. So we have to actually drag and drop the dog in there, not just one of the balls. The balls used to be destroyed if they were anywhere near the dog. And the reason for that is because of the hitbox on the dog, which we can edit by going to the dog prefab, opening the prefab and looking at this box collider. If we edit it, we see that now it's pretty close to the dog. It's good to have the colliders slightly larger because that's when you're playing a game, sometimes it's nice for it to still count nearby. Otherwise, it looks like it'll clip through the dog and still doesn't hit it. But it used to be giant and like way taller, way wider than it was supposed to be. Also, nothing was originally being destroyed off screen. The reason for that was because this script called destroy out of bounds wasn't attached to these objects and working properly. So the way that the script works is we have a limit for, we attach this to different objects. This same script works for both the balls and the dogs, both objects that can be instantiated and will go on forever otherwise. So if anything goes past the left limit, which would be the dogs, the balls are never going to go past there, then it'll be destroyed if once that X component is past that limit, which is off the screen. And then same thing for these balls. When they go past the bottom limit, which is 0, like where that ground is, once they go through the ground, basically they get destroyed to make sure that our game is being efficient, saving space. The next thing was that only one type of ball was being spawned by the spawn manager, despite us having all 3 of these different types of balls in the array. The reason for that was because of this random number that we need in spawn random ball. It was always choosing the same number to spawn from when it instantiated. It always picked the same index, but really we want it to pick a random number. Each time it spawns a random ball, we want it to pick a number between 0 and the length of the array, which is 3. And the reason we can do this is because this random.range will not pull the max value. So even though we can only use the numbers 0, 1, and 2, we would say 0 to 3 because it's non-inclusive of that 3 at the end. So each time that the spawn random ball is called, it picks a random number. Then it'll, at this position, generate a ball. Now also, originally in the player controller, we were able to spam the space bar, or in other words, press as much as we wanted and it would just keep working. So we implemented this cooldown feature so that it would take a certain amount of time before you could press or before you could instantiate another dog. So what this does is delta time is included to make sure it's a fixed amount of time. It doesn't depend on the performance of the computer and doesn't. But this update function, if there is a cooldown, it does this. It'll lower the cooldown by 1 and it'll skip this because this is an else if. So it'll only get called if the first if results in false, not true. But if there is not a cooldown, then we check to see if the spacebar is pressed. And if it was, then we can create a dog at that position and then set a new cooldown so that it goes through this update function this many times before you're able to spawn another dog. Similarly, the spawn interval was always the same at first for the balls. It would always be the same amount of time in between each new ball being spawned. And we actually discussed this one in class too. We ended up doing another cooldown, much like the dog for this one. I had originally thought that to do an invoke repeating with this would work, so that each time spawn random ball was called, it would pick this random number. But actually, if we do an invoke repeating, it'll just pick the random number once and do that same value each time. And also, I had thought maybe to do recursive, but as we discussed in class, that doesn't work because then we're never going to, the parent ones that call the recursive function are never going to resolve. It's just going to bog down the system and eventually run out of memory. So instead, every time it calls every update, or in the update function, we check to see if this cooldown generated by a spawn random ball is still active. If it is, we don't spawn one. We just run the cooldown down one like we did in the previous, or down one unit. That unit's going to vary, but it's based off time, not frames. And then if that cooldown's gone, then we'll spawn a new random ball and set the cooldown again. So with all that together, the game functions as it's supposed to. When the dog collides with the ball, it catches it. If it doesn't, the ball goes off screen, but is deleted. Everything works correctly. So next, we actually will continue to work on that project, the lab from the last video. So just as a reminder, the way that worked was we were given like an outline and we were supposed to kind of design our own game and how it would work based off this. Like we filled out this paper of like when the deadlines would be, how we would what we wanted our game to be. And so we actually did another lab that continued off that. There's another lab later on in this video that we'll cover, but for now we'll just cover the parts that were covered with this sequence in the Unity tutorial. So we actually learned about primitives and materials, which are really important because usually you're not going to have all of your like sprites or material, like you're not going to have all of your pretties right away. At first, you're going to be getting the functionality of the game down, and later on down the line is when you're actually going to make it look pretty and look like what you want it to look like. So for my game is going to be like a raccoon that's in the street and it can collect trash and throw it at cats and has to try to dodge cars. So in the hierarchy, I actually have these things named like the trash, the cars, the cats, but you can see they're just circles or blocks for now because that's the best way to start the game and implement and kind of framework how it's going to work. To make these, you right click, go to 3D object, and then you can create any primitive you want, such as a cube. I think it's also in this lecture that we learned about this transform component, which is really, or resetting the transform component, which is really useful for, because sometimes things just kind of spawn in the middle of the air. It's not where you want it to be. So you can click reset like that and then push it to where you want it to be. We also learned about materials, which are down here in this. We made a materials folder to make a new material, just like the other things. You right click, create material. For this tutorial, we just changed the color of them. So we can make a purple one, for example. And then with this new material, we can name it. And we can drag and drop it onto parts of our scene to color it. So I color this cube purple. Now it's purple. The other things in this tutorial I will cover later on when we actually got to that point in the lab. We did also learn at this point that you can right-click the assets folder. Actually, we should probably save first, just to be sure. So save, and then right-click the assets folder and go to export package. Select what you want to select, which usually would be everything. And you can actually export this. This is a way to back up your stuff for your games so that if something goes terribly wrong, you still have all of your assets, your scenes, everything's still there. Your entire game is backed up. Next up, we just took a quiz to cover some of the materials that we covered in the previous sections. Next up, we did this prototype that was actually a lot of fun and really cool. The first thing we did was we set up this background, which we learned we can change the sprite of with this part of the inspector, and we can choose all sorts of different things. I like the city. We also created our player, which we added a rigid body to give physics to. We changed the mass to be more realistic, and we played around with the freeze position and freeze rotation because in this game, the character be running straight forward. So if they collide with something, we don't want them to accidentally start like rotating in a weird way and then just like running sideways, or we don't want them to accidentally get off of this course. So the only thing we really want to change is the Y because the characters will be jumping, which, speaking of, if we open up our player script, we can see that there is this in the update function, there is this jump command that we have, which there's a few things going on. So if the spacebar is pressed and the player is on the ground and the game is not over, which we'll get into these next two parts in a minute. Basically, if the spacebar is pressed, then we add a force to that rigid body, which is like the physics controller of that player. It's going to be pushing it up, and then we set that is on ground. So is on ground is a Boolean, which is a true or false variable, and we use it to make sure the player can't double jump. We don't want them to just be able to jump in the air. And originally, if we just kept pressing space, we would just fly basically, but we don't want that. So being on the ground is a requirement for the jump to actually proceed. And we keep track of whether the player's on the ground or not by whenever they jump, setting this variable to false. And then down here, it's on collision enter. If the player collides with something that has the tag ground, then that is on ground tag is set back to true, or is on ground Boolean is set to true. So Unity doesn't just know that the ground is ground. We have to tell it that it has the tag ground. And the way that you apply a tag to something, such as the ground, is over here, this little tag area. There is all these different original options we could add, but we also added some more like ground, obstacle, background, bob, money. And you can add a new tag even by clicking this, clicking the plus sign, typing in a new tag. And then once that new tag is typed in, you go back to here and you'd be able to click that tag. Now, this third part of the jump of the if statement that sees if the player is going to jump checks if the game is not over. This exclamation point is a not symbol. So if this Boolean is not true, and this Boolean is handled up here, this game over, it starts off as false, but down here on this on collision enter, after checking to see if what we collide with is the ground, we also check to see if what we collided with is an obstacle. Again, that compare tag. So we have a spawn manager right here that spawns obstacles at a rate and then sends them towards the player with move left, which we'll get into that more in just a minute. But basically, these obstacles are going to be thrown at our player. And if the player collides with one of these obstacles, then we throw a game over message in the log. We set the game over tag to true. And that makes it so the player can't jump anymore, and actually does some more stuff that we'll get into as well in a minute. So first, let's go over the spawn manager. The obstacles that are being thrown at the player are handled by this. The spawn obstacle function is actually what instantiates. So until the game is over, we'll keep spawning things and throwing them at the player. But once the game's over, we don't want to keep spawning things. That would just look silly. But this is actually pretty complicated because what we're trying to access, this game over Boolean, isn't stored here in the spawn manager. It's stored over here in the player controller. So we had to learn something called script communication. And to do that, we actually have to assign this variable that holds a reference to that other script. So in the spawn manager script, we have a player controller script stored, and then we can reference that player controller script to access that game over Boolean to check to see if we just still spawn these here. Next up is this move left script. This is attached to the obstacles so that they can fly towards the player and give the actual challenge to the game the player has to jump over. And we have this left bound held because if the object goes past that left bound and it is an obstacle, then we want to destroy it. We don't want to make infinite of these and have the game bog down and lose memory. But you notice that we look for specifically the tag obstacle on this because this is actually applied to more than just the obstacle. This is also applied to the background. And so this is actually pretty interesting. The background doesn't only move left, it does. So it uses this to move with, it'll stop moving once the game is over, using the same thing that we just discussed a minute ago, referencing this player controller script. But also the background doesn't quite move forever. So this tutorial went into this in quite depth. It's actually a really interesting solution to this problem. So we want this background to go forever. We want it to look like even though it looks like the character is running in our game, like they're moving forward constantly, our character is actually in place. You can see that because we freeze the position of our character. What's happening is the objects are using that move left script to scroll towards the player, and this background is actually scrolling past the player to make it look like they're moving, but it'll eventually run out and then there's just nothing behind our player. So it's actually it's repeated right in the middle. You can see that it copies itself into the same thing twice. So this repeat background script waits until it is exactly halfway through the background, and then it'll reset its position to what it originally was. And the player won't be any the wiser because it looks the same to us. When the background flips from one to the other because it's a duplicate. But it'll make it so we can infinitely scroll because it'll just keep pushing back its position. It'll keep going back to where it was for as long as the game is running. And then of course, once the game ends, this move left script tells it to stop moving because the game is over. Next, we went over animations, which is something that I was very unfamiliar with previously, so I'm really glad that we did. So if you click on the object in the hierarchy that you would like to animate, and then there's this animator component that you can add. And if you double click the controller, you're brought to this really interesting looking screen. It's different from the rest of Unity. It looks a lot more like Unreal Engine actually. So you can middle click to move around or alt left click. And there's a lot going on here. So there's these states that there's a state that you start at, which in this case is a lot for the death. I'll move to the movement one. That's gonna be better. So there's a state that you start with, like entry run static, because in the game we actually want to start running. It looks kind of weird to like start walking and then running when the background's already moving so fast. But from each one of these states, you can transition to another state that's connected by these arrows, so long as the condition on the arrows is met. So for example, to move from run static to idle, this condition right here has to be met, which is that the speed _f tag is less than 0.25, which the way we would do that is by actually calling a method that would set this float to a number less than 0.25. And here's all those parameters. There's that float speed that we were talking about. There's tons of booleans, there's tons of other things. Then there's actually multiple layers. We also use this jumping layer in the game to move between idle and walk and run and running jump. So to see how we do that, let's go to the code and see how we can actually program these animations to happen. So for example, you might have noticed earlier that in our jump code, there's this line right here that says player animator or anim dot set trigger jump trig. So this player anim is actually up here. It's the animator attached to our player. It's that component. And we're able to do things. In the start function, we actually get it. We have to do the get once at the start of the game so that it actually exists to go grab. And then we're able to set this trigger because again, when we look at the animator controller, that's what's required to start that running, that jumping animation. And the speed is already fast enough to make sure it's a running jump animation. Similarly, down here, when the player dies, we set the death bool to true, and there's two different death animations there. So to differentiate between the two, there's a death int 1 that has one animation and death int 2 that has a different animation. And we prefer the first animation, so we set this integer to 1 as well. And those are what cause it, so that now if we go to our game, our player is actually running, the legs are moving. When we jump, we see that the player like waves their arms in the air, and when we hit something, they actually stop and fall. And then again, the background stops moving as we discussed earlier, objects stop moving as we discussed earlier. So the most obvious thing that we haven't covered yet is there's a lot of sound going on. When you jump, there's a sound. There's constant background music. And when you crash into something, there's a sound. That's all handled with audio. So the main camera has this audio listener, which is basically the ears of the game because sound is like direct. There has to be somewhere in the world that's listening to these sounds. You can't just hear everything's going on in the world all at once. So also alongside this listener on the camera, we also have the music as a source on the camera because we want it to be heard pretty much wherever. We want it to just be constantly in our ears like headphones. No matter where we walk, it's constantly there. So we have the sound. There's other things that can also play sounds, like on this player, we notice we don't actually have an audio clip in this one, but down here in the script, we attached different sounds from our sounds folder, which from these down here, we're able to drag and drop just like a prefab into this code. And then in the actual code for that player controller, when those things happen, like during the jump, we can actually do player audio, play one shot. So this play one shot means it's not like continuous like the song, it's just once. We'll do that jump sound that we assigned to that variable above, and then the volume of it, same thing for this death sound, where it does like the sound. And there's no code involved for the camera because the camera is just a sound snippet that's constantly playing and looping because we checked this loop box. The last thing is these particles. You've probably noticed these particle effects. There's the dirt coming up from behind the player as they're running. It's not happening in the air, but when they're on the ground, there's all those dirt particles coming out. And when we crash into something, there's that poof of like smoke. So both of those things are actually attached to the player is a parent object, and both the dirt splatter and the explosion are attached to the player, but they're set to play at specific times. There's all sorts of stuff that you can edit about the particle effects. But so while the player's in the air, we want to not have the dirt particles going. So when they jump, the dirt particle thing stops. And then once they collide with the ground, the dirt particle animation plays again. The particle effects, they start shooting again. And then when we first start the game, they're actually already going because when we first start the game, we're already on the ground. Also, the explosion effect happens such that when we collide with an obstacle, we turn off the dirt particle effects, and we play just once that explosion particle, that like the when all the smoke goes around. It looks sweet. With all that together, we got this actually pretty cool, actually kind of polished little game. So next, we actually did another challenge where they gave us a broken game and we had to implement the fixes ourselves. So the things that were broken, first of all, the player couldn't control the balloon. It would just kind of fall. And then even once we initially added the part where the space bar would make the balloon rise, it would rise way too fast. The background would only move when the game was over instead of while the game was not over. No objects are being spawned by the spawn manager, like the little monies and the little bombs. There's little fireworks effects that are supposed to appear during the game that were appearing way off from the balloon. They were not in the right spot. The background would like very obviously stutter, which is super disorienting. It wasn't repeating quite right. The balloon could float way too high. The balloon could just go on forever above, and it could go below the ground and go forever below the ground. So we can go over about 3 of those problems right now. This function for the movement of the balloon is inside the fixed update. So first of all, to make it so the balloon would actually, as you press space, it would actually go a realistic amount up. We changed this force mode to acceleration instead of impulse because that's more of how a balloon works. It doesn't just like boost up and then stop and boost up and stop. It's like a much more a gradual progression. This is also where we keep track of not letting the balloon go too high, because we can only part of this function, which is almost like our jump function. Part of the requirement to let us keep accelerating the balloon upward is that the transform position Y has to be below 15, which is about where the top of the screen is. So you can't continue to accelerate once you're past that point. And also, if you're past that point, then a constant acceleration force will be pushing the balloon down to make sure that it returns to the play area quickly. So it gives kind of like a bobbing effect at the top. Make it collide with the ground correctly. I added this there's these different compare tags. I added this one for the ground, and then I had to actually go assign a ground tag to the ground. So over here, ground, I added this tag ground. And what that does is whenever it collides with the ground, it'll give it an impulse upward to make it bounce up. So this is where we actually want to use impulse instead of acceleration, because it actually is like a bounce effect, like a sudden jerk of force. And then we also play an audio, so it gives a more realistic effect of the balloon actually hitting the ground. You hear like a boing sort of noise. The other problems were a little bit less code heavy to solve. The fireworks not appearing at the right place were just because this one, it was appearing all the way off to the side, and even though it's a child to the object, we still had to move the position so it was aligned with the object. The spawn manager was not spawning the money and bombs correctly because this invoke repeating was calling to the wrong function. There was a spelling error in here, and Unity wouldn't be able to detect that, or Visual Studio wouldn't be able to detect that either, because when we're doing an invoke repeating or a find object and we put something in quotations, it's going to search for that at runtime. So it's not going to know to check for that right now before the game's even running. Additionally, the background used to stutter because we weren't using the right numbers. So we had to fix it so that we find this repeat width to be exactly half of the size of the background. We find the size of the background because it has a box collider on it. The box collider is going to naturally perfectly fit to the background. And then once that background has moved exactly halfway through its rotation, then we put it back to where it was, just like the prototype, so that it gives like that smooth transition feeling. When we bring all of it together, the game looks like this. Background music and all. If I hold space, it makes me kind of bob downward. If I don't press anything, it bounces off the ground and gives that little sound effect you can hear. If I collect the monies, it gives little firework effects. And if I hit a bomb, the game stops scrolling. There's a big explosion effect, and I can no longer control the balloon. Finally, coming back to this junior programmer, or to the lab in the junior programmer, we added the ability for our player to actually move around. And we have rigid bodies attached to the player so they can't move through these objects, as you can see. And we also added these invisible walls around so we can't actually go past the areas. We can't just go off the map. The way we added those invisible walls was by adding this. So after we get the player's input, we check to see if they would move past our Z bounds or our X bounds, which is where our invisible walls are. If they would move past that, instead set them to where that wall is so that it kind of gives that illusion that there's a wall there because they can't actually go past that point. And then finally, at the end, we took another quiz to go over the things that we learned and make sure that we remember everything that we learned and everything that we covered. And that's all. Thank you so much for watching this video, and I hope you have a good day.